Okay, a note about electron configurations. If you did a search for electron configuration on the internet, an authoritative site that you can where you can find it is the physics.nist.gov. So what you do if you did a search on Google, you say electron configuration, and then you write the word site in colon. That way you limit your search to the site that you specify. In which case this is physics.nist.gov. And if you did that, you'll find one of the links there would be here, electronic configurations of the elements. Okay, and here's uh, the electron configurations for the neutral atom right here in this column. Okay, so you'll notice ground state for hydrogen's 1s1, helium's 1s2, lithium has 3 electrons, so helium core 2s1, so 3 through 10, that's row number 2 of your periodic table. Okay, now what happens when you get to the third row, or the fourth row, when you start filling in the D subshell? You'll find some few interesting things there. First of all, you'll notice that scandium is argon core 3d1 4s2, whereas we typically write it as argon core 4s2 3d1. So you might be wondering which one of these is right. Either one's actually correct, because when you're writing an electron configuration, all you're really specifying is how many electrons are assigned to a particular subshell. So it doesn't really matter in which order you write these. Okay, so it's like saying there's 2 people in bedroom number 4, 1 person in bedroom number 3, or there's nothing wrong with saying there's 1 person in bedroom number 3 and 2 people in bedroom number 4. Okay, so either way is fine as far as writing electron configuration is concerned. A few things you'll notice here too would be something similar to what you see here for chromium. It's an exception to the general pattern that we follow when writing electron configurations. This is actually based more on experimental data. And so the electron configuration for chromium, instead of writing that as argon core 4s2 3d4, okay, it's 3d5 and 4s1. Okay, this is the typical exception you'll find. Common exception you'll find is there's a shifting of electrons from one sublevel to another. So and the typical explanation given for this is that there is some kind of stability associated with with half-filled subshells. So remember, a D subshell is completely filled if it has 10 electrons, and an S subshell is completely filled if it has 2 electrons. So a half-filled D subshell would be D5, and a half-filled S subshell would be an S1. Okay, somehow if you could switch electrons around so you have half-filled subshells or fully filled subshells, they seem to lead to a more stable electron configuration. That's the explanation anyway. That's given. That's given for these exceptions. Okay, so if we scroll further down, you'll see more of these exceptions. Let's see. We have right here for copper. Okay, again, you see instead of 3d9 4s2, okay, you're seeing a 3d10 4s1. So again, shifting an electron from the 4s subshell to the 3d subshell gives you a half-filled subshell in the 4s and a completely filled subshell in the 3d. Now, this explanation doesn't always work though, because there's a few more exceptions where you cannot use where that explanation doesn't seem to hold water. So let's take a look at a few more exceptions. Over when you get to the next row in your D block, okay, you'll find that niobium is an exception. Okay, but by shifting, okay, instead of 4d3 5s2, and it is now 4d4 5s1. Okay, so you're shifting from a fully filled subshell to a half-filled subshell, but you're not gaining another half-filled subshell. 4d4 is not a half-filled subshell. Okay, Uh, Another exception you'll find is right here, ruthenium 4d7, 5s1. Okay, again, shifting from the 5s instead of 5s to 4d6, shifting from the 5s to the 4d, doesn't necessarily give you a half-filled subshell in a D subshell. Okay, so you're going from a full subshell, fully filled subshell in the 5s to half-filled, but you're not gaining a half-filled subshell there. And RH, what is RH? Here's another website. What's RH? Let me switch to this other table. You can find this one also on the NISD website. So we found we found ruthenium. Okay, it's an exception. Rhodium is also an exception. Okay. Instead of 5s2 4d7, you have a 5s1 4d8. Okay. Palladium is also an exception. Okay. Instead of a 4d8 5s2, it's just 4d10. Silver is another exception. Instead of 4d9 5s1, it's a 4d10 instead of 4d9 5s2, it's a 4d10 5s1. Okay, now let's look at a few more exceptions. You'll see even more exceptions when you get to when you start filling in the F subshells. Okay, so once you get to your lanthanide series, okay, here's an exception. You go with the 5D first before the 4F, but here you go with 4F first and then 5D. But instead of having a 4, so this should have been 4F1, but instead of 4F1, you have a 5D1. Here, instead of 4F2, you have 4F1, 5D1. Okay, so there are exceptions to that general pattern that you're taught in terms of coming up with electron configuration. Okay, and then here's another exception right here, the general pattern. Instead of 4F8, you have 4F7, 5D1. Okay, so let's see, what else do we see? Other exceptions can we find? That's gadolinium. And here in tungsten, okay, look at tungsten here. Okay, it's 4F14, but look at 5D46X2. This one, there is no shifting from the 6S to the 5D. You might have thought that if the argument that half-filled subshells have some kind of stability, you would have thought that 5D56S1 would be the electron configuration for tungsten, but it's not. Okay, so I think the best thing as far as these are concerned is just to be aware that there are exceptions, memorize the ones that your teacher expects you to memorize, and just go with that. And I guess you could memorize a typical explanation, but just be aware that that explanation is not really something that works in every situation about the stability of half-filled and completely filled subshells. Okay? And let's see, what other exceptions do we have here? Here's another exception. 5D, this one, okay, 5D9 6S, okay, and gold is 5D10 6S. So this should have been, if we were to follow the pattern, we should have written this as 5D10 6S2, but it's not, okay. And this one we could have written this as 5D. I'm sorry, this would have been 5D8 6S2, and this should have been 5D9 6S2 if we were to follow the pattern.